Assalamu alaikum. My name is Dr. Javed Iqbal. I am here with another video on machine learning lecture series. The title of this video is Data Augmentation in Computer Vision. We can also say these techniques to handle imbalanced data. Data augmentation is an important process in computer vision. It can be effectively used to enhance the performance of the model. This slide shows what is the motivation of using data augmentation techniques. As we know that in data augmentation, we artificially expand the data. Suppose we have this sample data of a line. After image augmentation, we can generate different variation of this image. Here are few different variations of the original line image. So data augmentation techniques can be used in a similar way in various other problems in computer vision. This slide shows what actually is data augmentation. Data augmentation is the process of artificially increasing or expand the amount of data where we generate new data from the existing data. We can also say that using data augmentation, we can generate synthetic data from the existing data. During data augmentation, we can apply different alterations or transformation to the data to generate the new data. Data augmentation is used to improve the performance of the models. It has been successfully used in various problems or applications in computer vision. Since there are several problems where we do not have sufficient amount of the data, in that case we can apply data augmentation technique to enhance or expand the data. It has been observed from the literature that data augmentation can be applied on training data only, but in some cases it can also be applied on the test data. But generally people apply it on the training data only. This slide shows various types of techniques that can be used in computer vision to perform the task of data augmentation. The first one is the color jitter. Next is shear, reflection, cropping, flipping, zooming, rotation, noise injection. Advanced neural networks such as generative adversarial networks GANs can also be used for data augmentation. Apart from this method, there are several other methods that can be used to perform data augmentation. This slide shows what is color jitter in data augmentation. In color jitter, we randomly change the brightness, contrast, and saturation of an image. Like in the image shown below, here we have an original image of the zebra, and after applying color jitter, we get different versions of the same image. The color jitter transformation can be like we have increased the brightness of the image. Somewhere we perform change in the contrast and change the saturation of the image. This figure clearly shows how color jitter can enhance or generate new images from the sample image. The next data augmentation technique is shear in data augmentation. In Shear, we will distort the image along any axis. For example, here is the original image. After y-axis shear, the orientation or view of the image will be changed. Similarly, after x shear, the orientation or the view of the image again will be changed. So, shear helps computers to see an image from different angles. Like as a human, we see images from different angles. This slide shows a reflection in data augmentation. In reflection, we can generate reflection of an image around different axes like x-axis, y-axis, or both axes. In the figure below, we can see in figure A, we have original image and the image B is the reflection of image A in x-axis and image C is the reflection of original image A in y-axis. This reflection process is also successful in creating new data from the sample data. This slide shows horizontal flips in data augmentation. Flips can be horizontal or vertical. In horizontal flips, the image is flipped horizontally. You can see here is a cat. After horizontal flips, the image will be changed. So we can obtain a new image from the this original image. This slide shows another technique of data augmentation. Random crops are scale in data augmentation. In random crops, we create a random subset of original image. For example, we have this original image of cat. Here you can see different rectangles of different sizes. We can crop the image based on these rectangles. Rectangles can be generated through different models. Based on these rectangles, the crop option can be performed to create new image from the original image. The next data augmentation technique is noise injection. In noise injection, we usually add noise into the original image. Jitter is also a particular method of implementing noise injection. Here in the figure A is the original image and figure B is the new image obtained from image A after applying salt and paper noise. There can be other type of noises that can be applied to generate new type of data. The next data augmentation technique is rotate. In this operation, we can rotate the image through some degree counterclockwise. The figure below shows this operation. Suppose here in figure A, we have the original image, and after applying some degree of rotation, here we obtain another image B. The image B is an augmentation of image A. So similarly, technique can also be used to create different variation of the original image. Like in previous slide, I have discussed only horizontal flips. So we can perform both horizontal and vertical flips in the same way. First image shows when we apply the horizontal flip, and the right image shows while we apply vertical flips. So our image data can be flipped horizontally or vertically to increase the size of the original data. This slide is about affine transformation. In our earlier slides, we have seen various types of transformations that can be used to perform data augmentation. In affine transformation, we perform various types of transformations such as scaling the image, translating image from one scale to another scale, from one axis to another axis, rotate the image. So most of the techniques that we discussed in earlier slides belongs to affine transformations. The next and the most recent technique of data augmentation is generative adversarial networks, GAN. GAN can also be used for data augmentation. GAN perform the task of data augmentation by incorporating random noise from the latent space and produce unique image. Latent space is the variable that are created by the model. These are the unknown variables that are created from the other variables. GAN is very much popular in generating new data from the existing data. The figure below shows this one is the image of real sample, and these are few virtual samples. Virtual samples are those samples similar to those we want to create new images. So using data augmentation, this one was the original real sample and these were the virtual samples. And after implementation of the GAN model, the model creates these new augmented samples. The augmented samples have both the properties of the real samples and the virtual samples. Actually, in the working of the GAN, we have two type of networks. One is the generator and other is the discriminator model. So we create two type of models, generator and discriminator. Generator generate new images while the discriminator model discriminate between the real and the new image. So it discriminate between the different images. This video shows several types of data augmentation techniques that can be used in computer vision. These techniques can be used to increase the size of the data or create new data from the original data. These techniques can be very useful in the problems where we have not sufficient amount of the data to train the model. There are a lot of computer vision applications that are using or in future several related problems can be solved using these techniques. I hope this video will be very helpful for all those who are working in the domain of computer vision, those also facing problems during their experiments due to very small amount of the data. In my next video, I will share data augmentation techniques in natural language processing. For more videos, please like, share and subscribe my channel. Thank you.